Initial checks completed. Backing up the configuration. Initializing databases. Establishing connection to satellite number 59. Loading intro. Rendering main control center. Loading custom components. The weather in Horsens is cloudy at 10 degrees Celsius. There is a humidity of 90 and a wind speed of 28.97 miles per hour. I am online and ready. Listening disabled.
So today I'm gonna record my first Java tutorial about setting the IDE and choosing the environment and the Java fundamentals. So let's get it started. First we need to get the Java environment. So what you wanna do, you wanna go to oracle.com, download index.html, and you're gonna choose the first picture here, which is Java for devices, and it will redirect you probably to the place where you go and click Java SE includes JavaFX, and this will allow us to choose both environments, which is Java Platform JDK 9, which is the newest for me now, and we will also want to get the IDE, which is integrated development environment for writing the code and editing it. So you just click to download. I already did downloaded it, and I've then installed it as well. And I have it. Yeah. So I got mine ready, and then you download the NetBeans, which is called IDE, Integrated Development Environment. There is also different IDEs, which is Eclipse, and it's released nearly every year under a new name, so you can always Google Eclipse versions, and there is newer versions than Eclipse, but all colleges always use Eclipse or NetBeans for Java, so I usually stick with them because they are the most reliable. There is also like newer ones like Helios or Neon and Oxygen and things like that, so you can find it on the internet, but I'm gonna stick with my NetBeans because I just feel very comfortable with it and it's good enough. So let's get it started. Open the NetBeans. And let's go to starting a new project. I'm only starting this series, so I'll probably have few videos for now, but I wanna show you how to use the Java to its cool potential, so finally you can do some cool projects with it. So let's go to File and New Project, and you will see the first window the way it is, it's just Java, press Next, and we're gonna name our project with tutorial 1, and you can choose the folder where you wanna place it. I'm gonna leave it with my project Java and really make a subfolder with the same name. If this create main class is unselected, you can select it so it will create the main class for us, which is pretty much handy. I have to say that I am programming since I was 15 and I have learned some C++ and Java, but I still have to like have backup projects for myself or write the functions into Notepad so I remember it. Probably not like that for everyone, but I feel it's handy because I tend to Google a lot of new things. So yeah. So let's start with comments. What you see on the top is like the forward slash and starts the comment. So basically the program does ignore the what's in between and then you close it also with star and forward slash. That's the multiple line comment, and also you have like double forward slash to make a single line comment, and basically you can leave a note in between your code, so it's easier to understand what you are doing. Okay, so at first we have a package. So package stands for a kind of a folder that will be compiled into your project, and you can have multiple packages, but we're gonna stick with one. And in future, when you make more files or classes, they all need to know which package they belong to, so they can like talk to each other. But that's for later. So the main class starts with public class tutorial1, which is the name of the file, and the most important is public static void main, which open the bracket, and in the bracket you have a first variable type, and it's actually a table. That means it accepts multiple of arguments, and this is the name. So um, okay, so I'll tell you about mm, libraries. There's few libraries that I gonna mention. I probably not gonna talk about them right now, but we're gonna talk about them in further tutorials. I just want you to know that the Java itself, same like C++, have only few things that we're gonna learn today, and if you want more, you need to find special libraries. They are mostly installed, so you just need to find the names of them, and you have to write a line which starts at import. So we're gonna import up our libraries like import java commands. And always at the end of the line you need to make semicolon, which is the dot with the comma. And it's good that we got an error here, and on the side which displays for us the lines. I hope you have it. It shows you somewhere in the window. I should have looked at it before. I hope it displays for you. So anyway, we have got this bolt. So if you click on it, it gives us a hint on how we can fix uh, the error, and you can often use it for quicker fixes. So basically, let's add swing. Okay, I think we need to import it. Wait, let me cut this out. Oh, basically what the error said is that we are importing the classes and the libraries, and we are not using them yet. So this is like we're using the space in the RAM memory, and we are not using the functions yet, so it's a waste of a space. So basically, if we compile our program and make it run, um, we will waste space because the libraries get included. Basically, the libraries are like a file like this, and you can hide them where you install the Java. and you can look what's inside, like it shows the code and how to call it. So we can look into libraries. But anyway, we're not gonna use them, so I just wanted to mention that it's in between the main class and after the package. So we're gonna remove them for now. And what we wanna learn about now is shortcuts. Well, I think the shortcuts are the uh, best friend of the programmer. So you probably know them, but I would like to mention a few of them. So Control C would be copy. And if I copy, then Control V we can paste this. And Control X is a cut. So if we cut, it disappears, and then if we Control V, it appears again because we pasted it. And Control Z would be to go back one moment. So if we delete it, and Control Z would bring you back, and Control Y would do the opposite. It would do one step forward. So basically, if we write some code and we delete it, and we can't remember what it was, we can always press Control Z and it is back for us. It is, I know it's okay. Might seem that I'm thinking or I'm not into it or something, but there's few more that are cool to move in the notepad. As you know, with the arrows you can move the pointer in between the characters, but with backspace you remove something. So if I mark something and press backspace, it will disappear. And uh, there is another bottom, delete, which is above the backspace. And what does it do? If you point the cursor on the front of a line, and it's actually deleting towards the right, and backspace is deleting towards the left. So that's something good to know because it will help you to move in between the lines a bit faster. Another ones are home and end. So basically, they're above the numpad, and if you press the home, it will bring the cursor on the front of the line, and if you press the end, which is on the right side of it, it will bring the cursor to the end of the line. So we've got home and delete and backspace, which are handy. You must know, like, to press the shift, if you click a cursor somewhere in the line, and press shift and click somewhere else, or if you already marked some bit and you want to add more selection, you press shift and then click somewhere else and it adds to the selection. And Alt Tab, which is handy for switching between windows. Whatever applications you have open, if you hold Alt and press Tab, you can see, like, you can choose one of the windows. I'm not trying to be smart, but I think it's handy to know it. So let's go further to Java fundamentals. There is two ways to call the uh, variables. Variables are saying that we're gonna use some kind of space for the future, like input or future memory, and that we're gonna use within the program. So there's two main things you need to know. This is public or private variable. And you always need to make it static if you make it public or private. So I'll explain it in a second. So there is few variable types, and let's start with integer. So what is integer? It's a variable that holds numbers. So if you want to make a space memory that will hold the number, you tell the compilator that it's integer by typing int, and then you choose a name, whatever name if you like, and we're gonna call it for the purpose a number. And then you either close it with semicolon and you can leave it like that, or you can equal it to, let's say, 5 because it's a number. And actually the integer holds numbers from 2,47,483,647 to its opposite value with a minus on the front. So basically we have 2 to the power of 31 minus 1 and 2 to the power of 31 negative. So that's a lot. Although sometimes there is a moment if you want a bigger number than this one here, and what we can't store it in the integer because it will be bigger. So what we need is a variable that's called long. So to make space bigger than what we had, like 2 milliards point 14, so basically we need a long variable. And long holds only a number, so we're gonna name it a long number and make it equal to this number here plus 1. We can add few numbers together in one, or multiply them within the Stalin compilator. Okay, so what we have here, we got an error because Java tells us basically if we are not in the main class, so if we put this one here, long variable into our main, we should not get our so with creating variables, there's two moments of making them. So first one would be called definition, which you actually make the type of it and the name of it, and then you make the second part, which is declaration. So basically, after somewhere else in the code, you can go with the name of the variable without telling what it is because we already have this variable, and we can make it equal to something. Yeah. And we have another problem that we're gonna resolve right now because there's two types, like I said before, which is public or private. So basically, if you're not gonna tell the compilator that the variable is public, that means it could be used outside this kind of bracket. The variable will only work within this bracket. So basically, if they are private, we can have multiple variables with the same name and same type just somewhere else in the code with a different class or different function. But if they are public, and we're gonna make it public right now, so our main class gonna see this one. So if we need to name it public, public, and always after public comes static. Like that means we actually have this number, and uh, we can also have private static, uh, which will only allow us to use the variable within the class, and you can declare the private only in the main class, I mean outside the main class, in the main file. But if you create within the main class a variable, and let's say we're gonna go int or long uh, long number, it won't show us an error because it's straight away private because we never told it that it's public. So we can have one long number in the big class and one long number within the main. So we always split into definition and declaration. So the definition and declaration uh, will be outside the main on the big class, and definition would be either like in our main class or just assigning a number to it, because later on if you try to use this number it was never assigned, then it will give us an error. So we got an integer and long. Now we learn about the float and doubles, which is the um, like numbers with a comma. That means uh, it's float and doubles. So basically we have a float, floating point. This is our name of the variable, and we'll have a double, which is the longer version of float, and it just holds more numbers within it, but it's also a number with a comma. So we can make it equal to like 1.5. Also, yeah. I don't know why we get this. I think we need to use a dot, not a comma. So double point. Okay, so let's learn about their sizes maybe, just to compare. An integer number can range like between positive and minus 2.14 milliards, billions or whatever it's called, like more than million. So let's give it this size for the purpose of seeing it. Um, I don't know why it will give an error. It shouldn't be. I think we need minus 1. Yeah, so we got it. Yeah. So there's two buttons. There is three. Build a project, which actually like remove all the files that we previously compiled and make it again, or clean and build, the uh, faster way of rebuilding our project. And I will take this one. And there is a play that run the our project, and it works, but we haven't do anything yet. So let's learn about those numbers. Long number can store between like what the like quadrillion, nearly 9 quadrillions or something. And what is that? To make it easier for us, we're gonna go and use logarithm, which is handy function. You can find it in a calculator, but I don't know how to use it, to be honest. It's a log, you know, but I found this handy website. So we're gonna write this number here without commas, and see what we get if we logarithm is the base of 2. So basically it's uh, like third way of saying uh, like there is powers, and there is uh, square roots, and there is logarithms, which is another part of the same thing. So basically if we get like 2 to the power of 2 is obviously 2 multiplied by 2 and it's equal to 4. So basically if we get square root of power 2 from the number of 4, it will give us 2. That means um, how many times will we divide this number? No, if we divide this number square root, you probably know what it is. Like if we go 8, um, it will give us like um, I'm so bad at math. I mean, I love it, but I should study more. So basically, if we put it to the power of 3, it will give us again 2 because it's asked us what number multiplied this many times by each other gives us the number here. So 2 by 2 is 4 and by 2 is 8. And we have logarithms as well, which is logarithm of the base of 2. We want log 2 from the number of certain. It asks us, let's say 8. Let's figure it out. So basically, it asks us what power would we need in order to get this number from that number. So basically, if we put our long range number into logarithm and make it to the base of 2, it will give us this handy number, which is 2 to the power of 63. Yep, on the other way, it's a log to the base of 2. And it's this weird number here. Effective 2 log from the number of power 2, and it will tell us that we need to square root the 63. If we put the number 2 to the power of 63, it will give us this value, which is the length of the long variable. So let's go back to the reader, and we have a float and double. And we're gonna learn now how to print out some information. So within our main method, we wanna write system dot out dot print ln and open a bracket, and we want a double count. What is this called? The bunny ear, double bunny ear, the quotation syntax, and we can display hello world. And basically this only keeps the memory, so it won't do anything for us. We compile it and display, and we get here hello world. So this line here displays the whatever is inside the bracket. So if we wanna ask ourselves what's the value of this number here, or tell it to the user, we're gonna say number and outside because this holds only a text. So if you want to add a variable, you need to go outside the quotation and add plus between each argument, like number or variable, and add the name of the variable. So number. Put it static into the number. And implement it equal this. I don't know why we can't find it. So no, it's local variable. Okay, it's weird because we made it public static in, so that means we could reach it whenever, wherever in our class, like in our file. And it was meant to be integer. Okay, and like I said before, it has not been initialized, so it's not been defined. It have been declared right here, but it holds nothing. So it's gonna make it. I don't know. This should work. I think let's do even outside this, but no. Yeah. But then we need to only declare it. Here and make it just without it should work for me. Yes. Mm, yes. Okay. I see now because I removed the wrong sign. So basically, if we make it outside public static integer, we will see it also in the main class. That is the reason. And private long will not appear, so make it as well without calling private long, just long. So yeah, we want to see what is the number. We compile it, find it, and the number is subtitled and there is a variable. And we're gonna learn one cool thing, which display as a value of a float and double point, the maximal range. So basically, we got this long number. Oh, and there is also final. So static final long final. Oh, I know. We make it equal to this number here, and it should work for us. And what final does, it tells the compilator that this value here cannot be changed. So like if we make final integer, final public static, and we call it 5, and make it equal to 3.14, we will be able to use int. I don't know why I'm making so many mistakes. I'm actually drinking a beer with a ginger and curcuma with some apple juice. So maybe that's why. Cheers. So we're gonna make it nice and easy. So this one. And let's cast it to long I don't know why. So basically, okay, let's find out what is the length of the long variables. Let's put it in the comment and let's use the other function that I wanted to show you. And we're gonna display it with the same function system.out.println, but I want to teach you another shortcut. If you type in SOUT south and press the tab above the caps lock, it will write the whole syntax for us. So that's another handy thing. And we want to ask for a max value of max of long is equal to close long max value. I hope it works for us. And we're gonna do the same for the float and double values. Okay, so I think it's gotta be a capital letter and it works for us to compile it and run. So basically we got a maximum of long is, so let me, so basically this should have worked. Now I give us an error. Basically, what we get, we have, we go to my computer, and go to properties, we find our Windows version, and I got a 64-bit, and I think my Java is only 32-bit, so this might be the reason why our length of values might not be the same, because obviously 64-bit can hold definitely longer numbers than a 32-bit system, and I can show you on the calculator. Oh, there's another shortcut in between the Control and Alt on the Windows keyboard. You have this window button, so if you hold this and press R, you will pop out the run, and you can use it to mspaint.exe, notepad.exe, or I always call calc.exe. And if we change it to the programming stick, we can change in between hexadecimal, decimal, octal, and binary. So if we go to binary and make 32 ones for a 16, and this is 32. It's actually in decimal, it's like 4.5 million, a million, billion, whatever it's called, like 4 and then 9 digits above. So basically 64. Hmm, I think this is 4. Further. Um, yeah, it's gotta be 63 because the first digit of a 64 is a declare whether it's a positive or negative value. So basically, this is a huge number that stores in a 64-bit and 32-bit system. So we might get a slightly different. Number is correct, so let's seriously, this is okay. I remove this. Come on. I compile it again. Let's see if it works within our main class. It's this way. Oh, because it's probably stores the values from 0 to that, so basically it's minus 1, and this should work. Okay, so we got our floating point, which gives a number with commas, and our double point, which stores way bigger numbers because floating point stores some number with like 48, 45 place or 46 digits, and this holds about 300 digits double. So yeah, there is a major difference between them. And what else? Don't worry, we got a char. Uh, it's a character, and in order to assign a single character to it, you need a single bunny ear, and we let's say give it 8 as a character, or it could be a digit, but it's not the same as an integer. It's a digit, on the chart, but it can be stored here as a subtitle. And longer version of character is a string, and it's the only variable that it starts with a capital letter, and it's string sentence. And you equal it to the double bunny here, and make hello world. Can always display as well by providing the value. So what else is there? We got our variables, characters and strings. So it's time we learn about tables. So a table is a multiple space variation of the any of the variables. So basically, if you want to hold a few sentences under the same name of a variable, we got a string sentence and lots of numbers. We use numbers to defend here, and you make the square bracket after it, and you always need to equal to the new integer and make the bracket and assign a value to it. So let's say we want the 5 numbers and close this back to the subcolumn. So now we can do like type in lots of numbers, uh, bracket and 0 because basically we gave it 5 places, but the first one starts at 0. So basically what we will have is uh, 0, 1, 2, 3, and 4. So this is 1, 2, 3, 4, 5 places starting from 0, but it's one less than what it happens. So you always need to remember this. And then you can assign it a value of whatever it is. And if we can use another place to give it another number. And in order to display it, you type in south and press tab, it's system.out.print ln, and we display lots of numbers, 0. Uh, we want only a sentence of saying that we're gonna add it to lot of numbers 1. And now we can also display actually like connected numbers. So we could go like lot of numbers from 2 will equal the lot of numbers from the table 0 and 1. So basically let's display what. And actually it will say exactly the same as if we type it here but in a bracket. Don't use the back bracket. So if we fire this and compile it and run, it will give us the 14,000 out of 4 and 9,000. And we could also display it as this number here. So yeah, we got the tables, and there is multiple dimension tables where you can make double brackets. Oh, as a as my own experience, I'd recommend you to always first declare the variable outside the main class and make it public static if we want to use it everywhere in our program, and then only use the name of it without another again assigning, because that way the code will clear and uh, you can use it anywhere. And after the main will be very messy, and you can always make another class, actually function, public static integer, and what differentiate function or class from the variables, you just give it a bracket and then the kind of curly bracket. Oh, we didn't do it, and I call it init. Oh, actually, we need it void, because if you give it a variable syntax, we will need to return the value, and the void returns no value. So we need no return statement at the end. So basically, if we create a new variable, like a double uh, table, static in maybe, uh, two-dimensional, and make it equal to. See, with tables we always need to give it equal to the itself, new int, and same amount of brackets that we put. We could put 3 brackets, but it's it's a little bit harder to use it after. So let's keep with 2 for now. Um, we give it a values of 5 and 5. Okay. So, now we could give it a numbers like we did here. I put it to our void function, and we're gonna call it. Okay, so see, there is a problem just because we didn't put that variable integer lots of numbers outside at the very top and make it public static. We can make them all private static or public static. It's a very good like public static. So this is our declaration, and then we can define it. So yeah, we can't use this variable anywhere else because it was only within our main, and this is the problem. That's why we always first declare, and if we move this upstairs, like here, it doesn't change anything unless we make it public static. And see, now it's works everywhere. So we got those numbers in it, and we compile and run, and we got 0 equal to 0, just because we need to, this part of the code didn't get executed. So this is our function, and we can use it by saying a name of it right here before we want to display it. Init and the brackets and close it. So basically what does do at this point of our main, the code tells us to go here, execute this part of code, and return here. And now if we compile it and run, we got our values back. So this is pretty handy. I have to say that, like, yeah, we could get parameters here, so if we, yeah, we'll do it now. So we got our tables in multiple dimensional tables, and we need to learn if statement. So basically, maybe we like remove some of the code, just this one, and make an if statement and ask our compilator. And this is logic gate. So basically, there is different logic gates. You can read about it, how they work, and there's 2 operators of them. So like a bigger or smaller characters, and there's few different ways of doing it. In the if statement, we need to give 2 arguments that we will be comparing. So basically, let's ask if our variable lots of numbers 0 point is greater than the other one, lots of numbers table 0.1. Then we open curly bracket and we type in uh, the, the bigger number is, and we ask this is the bigger number, so we want to display this one. And now after the bracket of if, we can type in else and open bracket. That means the opposite of if. So basically, if this number is bigger, we're gonna display this one, and we compile it and see which one won. The bigger number is 9,800, which we held in state number 2. So this is our if-else statement. We have more of choosing possibilities. I usually to choose between multiple of ways I use if-else, but sometimes I use the switch statement. But maybe before switch statement, we learn the loops. There is 3 different loops that we know. There is while loop, do while loop, and a for loop. So basically what they do, it's similar to the if statement. So while, uh, let's say, while our number lots of numbers 1 is bigger than lots of numbers 0, then we open a bracket and we're gonna subtract the lots of numbers 1 by either making it equal to itself minus 1, or there's another way of doing it just by minus minus. That means we only subtract by 1. Or you can make it as well. Third way of doing it is minus equal to 1. So basically it will subtract or minus equal to or whatever. So there's 3 ways of moving the number inside. We're gonna maybe stick with minus minus. So this is while loop. While this one is bigger than this one, we're gonna subtract 1, and after it finishes, it's gonna come out and about our number. Lots of numbers. 1 is 4,564. So yeah, and there is another loops than while. It's basically do, and you open the curly bracket and you type whatever, like lots of um, minus minus, close it, and after it, it's like else you do while and open normal bracket and give it the same. So basically it will does the same thing as the while loop. It's probably much handier, but you can first tell what to do and then give an argument when that happens or how long. And let's see. Yeah, we got the same result. So what I prefer the while loop, and you given first in a normal bracket the reason when to stop, and like inside the bracket what will happen while it's looping. And it won't stop before, but we can, let's say, make a stop by calling a break function, which will be used later. It will move out of our loops. So if, let's say, numbers 1 is equal, and we got two different moments of a equal operators, because if we compare some variable by not making greater, we have to put a double sign, because if we put a single equal sign, we'll actually give the variable here its value. But if we compare, if it's equal to something, we put double equal. So if it's equal to 5000, we will break. And break doesn't work for ifs. It works for while loops and classic, I think. So basically now if we compile, our loop tries to continue until this is bigger, but it's stopped at 5000. And we have another last loop which we will use, and it's a for loop, and basically we will use it to fill out our huge container with 10 spaces, which is from 0 to 9. And we'll do it in the initialize by saying for this is our starting point. We create an integer at 0. There are 3 arguments in the for loop. First one is a starting point. The second one is argument when to finish the for loop, and the third one is how fast we're gonna increase. So for in e is equal to 9, because this is our size of our last space of our table. Even though it has 10 spaces, it goes from 0 to 9, so from 0 to 9. And we're gonna only increment it by 1. And now we can back it up here, and maybe one line will be enough. And here in the parameter we type in e, and let's make them equal to e multiplied by 100 or 1000 or whatever. So basically different values. So this is our for loop, and it's the only for loop that picks exact amount of time. Otherwise you go from 2, and this you can tell it when to stop. In the while loop or if statement, there is going to the logic gate. Basically there's few logic gates. It's a less, greater, equal, or less or equal. There is greater or equal, and this is used to compare. So we can put it always in a comment, multiple line comment, just so we don't get an error. And this is our logic gate operator. And we have few more. There is AND, double and that will allow us to put few comparison, or it's under, I got it inside the left sheet, is the next character. If you can play this character, it's a line, and we need two, or this is less than equal, equal, less or equal, and an or. So basically I'll try to implement and an or in a moment, but we type this somewhere our logic. And We can do also a nested for loop. So a nested for loop would be a for loop within a for loop. What would that give us? Let's write it in the beginning. Oh, basically the integer that we created here is a private, so it's only within this bracket, so we can have another for loop outside this bracket with the exactly same integer. So we call it x or I as well, uh, and make it equal or less than 5. That's probably gonna work as well uh, as 0 to 4. Then this, then it will be 0 to 5 is going to be deductible. So we're gonna keep increment it. And let's write another time this inside, but we can't use I because it's already used, so let's use J. Or let's make this X and Y. And let's make exactly the same, right? Incrementing Y. So why do we do this? Because we got our two-dimensional table with two parameters. So what that will do, we'll put X and Y and make it to, let's say, well, first we're gonna look at the X-axis, that is horizontal, and then we're gonna, well, on the outside it should be Y, because we wanna make a column outside, because they will increment only after the inside increment, and the middle one will be the X. So would that give us to make two-dimensional table that holds like 1, 2, 3, 4, 1, 2, 3, 4, 5, 3, 4, 5, and 3, 4, 5. Actually, it should be starting from 0 to 4, but yeah, this is our table, and that's what we want to get. And basically, what we do by moving the y, which is columns, we what we do first, we make it 0 here. So and what happened after, we make x 0 as well, but we won't leave this until our x is finished to 5, and then we're gonna make our y 1 and make all x's, and so what we're gonna fill it the way we read the book, so like that way, and then one down, and that way, and one down. So let's make it equal to the x multiplied by y. And maybe let's give it yeah, let's do it on that. Maybe let's create a table there. Yeah, so we fill out this with x multiplied by y. So 4 by 4 is 16, so our last digit would be like 16, because we don't get this because we got a zeros as well. So 2 by 2 is 4, this is 9, it's 14, let's maybe skip this. We did a for loop, we did a nested for loop, we did a while loop, do while loop, and last thing which we need is a switch statement. And we go to the end of our main class. If you click on the front of the main class the curly bracket, it will spark the end of it in the NetBeans, so we know where is the end of this class. And if you go at the very bottom, in my case, where I can see the top, and I place this curly bracket outside, it's even displayed the note what it belongs to, like what's the name of the start of it. So let's go into the end of the main and then switch statement. And what we want to switch is switch and open a bracket, and let's get some number, some easy one. Our number, and like let's make it equal 5. Fine, okay. Or and let's make it equal 3. Okay. And let's switch it. So it takes one parameter to open the curly braces, and inside we ask uh, in case. This is another syntax which is used within the switch. It's called case, and then in case this number in the parameter is 0, the double dot and open curly brackets. Let's last is 0. Let's say just like that. Okay, and we're gonna do this multiple of times. Let's say 3 or 4. So basically, oh, we will get a awkward situation here. Let's see the outcome of it. Okay, so we are here. Last line is 2, but last line is also 3. Why did that happen? So basically our number was 2 and went up to here. So this case is just because we were still inside the switch statement. So what we need to do in the case of 2 is called a break. That means it will now go into other shells underneath it. So basically if we don't do a break and make this number equal to 0, it will show us in all the tables below 0, 1, and 3, 1, 2, 3. And if we make it break out after, just like we broke from a while ago, then it stays only the last line is 0. So basically you always want to put a break statement uh, above, underneath the case, at the end of the case. Uh, and now it should be open. So we learned if else, switches, our all signs of variables like integers with long version, uh, float point with comma numbers, and double, which is a longer version of it, and strings and characters, and displaying, and do while, and for loops, and tables. And this is like a nearly whole book about C++ or what you learn on the first year uh, of the college. So I hope you enjoyed it, and yay. good luck. Subscribe, leave a comment if you have any questions, and I hope I make more of them. So press a like. Oh, and if you wanna see more of my work, I'll welcome you on my Patreon, and I'll leave probably the links somewhere on the website. Um, I'm making cool projects right now. You can subscribe for monthly payment. Um, I'm working on two projects actually, a data lab and a game project. I'll be updating it. And I'll try to record more tutorials as well, so see you around.